much can we really know about the universe beyond our galaxy? The Hubble telescope has enabled us to see objects in space as far as 13 billion light-years away. But this still doesn't give us the answers to all our questions. Questions like, what is the universe made of? Which elements are the most abundant? Does space contain undiscovered forms of matter? Could there be antimatter stars? Or galaxies? Some of these questions cannot be answered solely from visual images. But what if we had messengers bringing us physical data from distant parts of the cosmos beyond the reach of explorers or satellites? In a way, we do, and these space messengers are called cosmic rays. Cosmic rays were first discovered in 1912 by Victor Hess when he set out to explore variations in the atmosphere's level of radiation, which had been thought to emanate from the Earth's crust. By taking measurements on board a flying balloon during an eclipse, Hess demonstrated both that the radiation actually increased at greater altitudes and that the sun could not be its source. The startling conclusion was that it wasn't coming from anywhere within the Earth's atmosphere, but from outer space. Our universe is composed of many astronomical objects. Billions of stars of all sizes, black holes, active galactic nuclei, asteroids, planets, and more. During violent disturbances, such as a large star exploding into a supernova, billions of particles are emitted into space. Although they are called rays, cosmic rays consist of these high-energy particles rather than the photons that make up light rays. While the light from an explosion travels in a straight line at its famous constant speed, the particles are trapped in extraordinary loops by magnetic shock waves generated by the explosion. Crossing back and forth through these magnetic field lines accelerates them to almost the speed of light before they escape. There are lots of cosmic rays in space, and some of these particles have traveled for billions of years before reaching Earth. When they enter our atmosphere, they collide with the molecules there, generating secondary cosmic rays, lighter particles with less energy than the original. Most of these are absorbed into the atmosphere, but some are able to reach the ground, even passing through our bodies. At sea level, this radiation is fairly low. But people who spend a lot of time at higher altitudes, such as airline crews, are exposed to much more. What makes cosmic rays useful as messengers is that they carry the traces of their origins. By studying the frequency with which different particles occur, scientists are able to determine the relative abundance of elements such as hydrogen and helium within the universe. But cosmic rays may provide even more fascinating information about the fabric of the universe itself. An experiment called the Alpha Magnetic Spectrometer, AMS, has recently been installed on board the International Space Station, containing several detectors that can separately measure a cosmic ray particle's velocity, trajectory, radiation, mass, and energy, as well as whether the particle is matter or antimatter. While the two are normally indistinguishable, their opposite charges enable them to be detected with the help of a magnet. The Alpha Magnetic Spectrometer is currently measuring 50 million particles per day, with information about each particle being sent in real time from the space station to the AMS control room at CERN. Over the upcoming months and years, it's expected to yield both amazing and useful information about antimatter, the possible existence of dark matter, and even possible ways to mitigate the effects of cosmic radiation on space travel. As we stay tuned for new discoveries, look to the sky on a clear night, and you may see the International Space Station, where the Alpha Magnetic Spectrometer receives the tiny messengers that carry cosmic secrets.